We're going to start the second part of our quadratic function unit today. So our first lesson for today is going to be simplifying square roots. And so simplifying square roots is a lesson we probably should have done in middle school, but because of our crazy year last year with COVID, it probably didn't get taught because you weren't in school all of second semester. And so we're going to fill in that hole today by teaching you how to simplify square roots. So a square root is the inverse of squaring a number. So what I mean by that is those are inverse operations, just like addition is the inverse operation of subtraction, multiplication is the inverse operation of division, squaring is the inverse operation of square root, or square root is the inverse operation of squaring. So since we know that 4 squared is 16, we can then say the square root of 16 is 4. So what we're doing here is anytime that we are taking the square root of something, we are looking for a pair of numbers that when I multiply it to itself gives that number. Since 4 times 4 is 16, the square root of 16 is 4. So we're looking for pairs of numbers. So what happens if it's a square root we don't know, like 52? So there are several ways to go about this, but we're going to teach it one main way, and that is to first create a factor tree for 52. So we're going to ask what multiplies to be 52. I know 52 is even, so I can take 2 times 26. 2 is prime, so I'm going to circle that number. I am now done with the 2. However, 26 is not prime. It is still even, so I can divide that one by 2. 2 times 13 will give me 26. 2 is prime and 13 is prime. Since all of my ends are now prime, I can rewrite 52 as 2 times 2 times 13. So all of those ends that I circled, if I multiply those together, it will give me 52. Now, what we're looking for is a pair of numbers. Just like that 4 times 4 gave me 16, well, right here we see 2 times 2. So anytime you see a pair of numbers, that pulls to the outside as that single number. And so on the outside, I would have 2. So this is 2 square roots of 13. And that would be my final answer. So if we look at our next one, 45, we're going to create a factor tree for 45. I know that 45 ends in a 5, so it's divisible by 5, so that'd be 5 times 9. 5 is prime, so I'm going to circle it. 9 is not prime, so I'm going to keep going. 9 is 3 times 3. 3 is prime, so I'm going to circle those. And I'm going to rewrite 45 using those prime factors. So that would be 3 times 3 times 5. I'm looking for a pair of numbers. I have a pair of 3's, so that 3 comes to the outside, and then there is a 5 left underneath our square root. So we have 3 square roots of 5. The next one is the square root of 80. So again, we're going to create that factor tree. Most commonly, I think people are going to see 8 times 10. Neither one of those are prime, so I'm going to keep going. 8 is 2 times 4. 2 is prime, so I can stop on that end. But I do have to do 4 because 4 is 2 times 2. The 2's are prime, so I'm now done with that side of my factor tree. And now I'm going to go back over to the 10, and 10 is 2 times 5. And 2 and 5 are both prime. So I am now completely factored. I'm going to rewrite 80 as 2 times 2 times 2 times 2 times 5. So I have a pair of 2's. So this pair of 2's pulls out as a 2. I have a second pair of 2's. So that pair pulls out as a single 2. And then I have a 5 left underneath. So when I pull out multiple numbers, since these are factors, factors are being multiplied together. So when I pull out those 2 2's, I have to multiply them together so that it becomes 4 square roots of 5. Now, if you notice on this one, we have 3 square roots of 54. There's a 3 in front. So the only difference is that when we write this, there's already a 3 on the outside. So that 3 has to stay. And we're going to create a factor tree for 54. So I could do 2, because 54 is even, and 27. And then 27, I could break down into 3 times 9. 3 is prime, and then I'm going to keep going with the 9. 9 is 3 times 3. So I'm going to rewrite 54 as 2 times 3 times 3 times 3. And I'm looking for a pair of numbers. I have a pair of 3s. So that 3 pulls to the outside with the 3 that's already there. So I now have a 3 that's already there, a 3 I'm pulling out to the outside, and underneath I have a 2 and a 3. So since these are factors, remember they all get multiplied together. So 3 times 3 is going to give me 9. So I have a 9 on the outside. And 2 times 3 is going to give me 6. So I have a 6 underneath my radical. So that's 9 square roots of 6. 2 square roots of 180. So I'm going to factor 180. So I think 180, most people typically see 18 and 10. And then we can break down 18 into 2 and 9. 2 is prime, 9 is not. But 9 does break down into 3 and 3, which both 3s are prime. And then we can go back up to the 10, which is 2 times 5, and both 2 and 5 are prime. So when I rewrite this, I'm going to keep the 2 on the outside that's already there. And I'm going to rewrite 180 as 2 times 2 times 3 times 3 times 5. And I'm looking for pairs of numbers. I have a pair of 2s and a pair of 3s. So my pair of 2s pulls out as a single 2. My pair of 3s pulls out as a single 3, and there's already a 2 there. So I have a 2 that was already there, a 2 that comes to the outside, and a 3 that comes to the outside. And the only thing that is left underneath my radical is the 5. So again, I have to multiply these together. 2 times 2 is 4, times 3 is 12. So I have 12 square roots of 5. And then tomorrow we will actually talk about the square root property.